Hi, Year 11 method students. Right, we're going to do arithmetic series today. Right, you should make sure you have finished all the sequences, videos. There are three arithmetic sequences videos, and also there are three videos for geometric sequences. Okay, let's begin. Okay, so for arithmetic series, first we need to define what is a series. Right? So the definition here, a series is a sum of certain number of terms, certain number of terms of a sequence. Okay, so the key word here is about the sum. Okay, it's about the sum of number of terms of a sequence. Also, it is from a sequence, so it's a sum of sequence, simply put. Right? So for example, if there's sequence T1, T2, T3, etc., we use Sn equals T1, so there's no comma, right? Okay, so it's a typo. T1 plus T2 plus until Tn. So Sn means the sum of first n terms. You might memorize this like that. Is the sum of the first n terms of a sequence. Alright? Okay, for example, if I give you a sequence 1, 2, 3, 4, okay, so that's an arithmetic sequence with common difference 1. Okay, so S3 means what? S3 means the sum of first three terms in the sequence. Alright? So that's 1, 2 plus 3. Okay, so of course, if you like, you could calculate the value, but we are not interested in answer yet. We just want to write the expression. S6 for the next one. Okay, next one is also an AS with common difference 2, right? 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Okay, S6 will be 2 plus 4 plus 6 plus 8. Okay, not finished yet because you need to write 6 terms, 10 and 12. Okay, so that's S6. How about S8? So that means the first 8 terms, that will be 10 plus 7 plus 4 plus 1. Okay, so what's the common difference here? The common difference should be minus 3. So every time you take 3, plus minus what? Minus 2 plus minus 5. Okay, so how many terms now? 6. Alright, so plus minus 8 plus minus 11. So that would be S8 for the sequence, right? And so for an arithmetic sequence, AS, okay, can we find any general rule for us to find Sn for an arithmetic sequence? Alright, so actually there's some general rule for Sn. The general rules here, but I'm going to explain to you why we will have such general rule. Okay, consider one particular AS, the very common one, as 100, right? So the sequence is the most common arithmetic sequence 1, 2, 3, 4, 5. So 1 plus 2 plus 3 plus 4. So every time I increase by 1, okay, so I'm going to write the last 4 terms as well. 90, oh sorry, should be last 4 terms, right? 97, 98, 99, okay, and then what? 100. Okay, so that's the sum of first 100 terms. But how can we find the sum? Of course, you can use your calculator to add one by one, right? 1 plus 2 plus 3 it might take you some time, but do we have a quicker way to do it? Alright, so let's consider another way to write this as 100. Can we write it the other way around? Like, instead of starting with 1, I start with 100. Is that okay? Yes, of course. This one is still the same. You could say it's a bit different because the common difference becomes -1. But actually the value will be the same for arithmetic series because you just change the order of the terms for the addition. And we know that if you move 100 to the front, 1 to the back, you will still get the same sum. Alright? Okay, first you need to understand these two S100 would be the same in terms of value. But how about when you add them? Let's say when we are going to add them together, we try to add the two lines together, right? Okay. On the left hand side, that will be 2 times S100 because that's 2 S100 add together. Okay, for here, 1 plus 100 is 101, 2 plus 99, 101, 3 plus 98, 101, 4 plus 97, 101. Alright? And here, 94 plus 4, 101, 101, 101, and 101. Okay, so the amazing thing is all these number 101. Okay, my question is how many 101? Okay, how many of them? Okay, of course there should be 100 of them because in our series we actually write 1 plus 2 until 100, so that means that 100 of them, 100 terms of 101. Alright, so how could we summarize that? The right hand side, it should be 101. It should be 100 times 101 because that's 100 101, right? Okay, so how could we find S100? What you need to do is divide the 2 over here and times that 101. Okay, so that will give you 50 times 101. Okay, and that will give you, so we could even do it without calculator. Okay, so that would be a quicker way. So from this we actually could see something, right? So how could we, what's the meaning of this 100 here? This means the number of terms. Okay, so just like this, just like S100, so that 100 terms, so that's 100 means number of terms. Okay, how about this number? This number is from 1 minus 100, 2 minus 99. So simply we could say this number is our T1 first term plus T100, right? First term plus 100th term. Okay, so if we could see it, we could say S100 equals number of terms divided by 2 times the sum of first term and the last term. Okay, that's how we get this formula or this rule for Sn. Okay, so you see Sn means the sum of first n terms. It equals number of terms, which is n, divided by 2. Okay, just like 100 divided by 2 times bracket first term plus last term. Okay, so do we have another version? Yes. How could we get this version? So the version, the green box, how could we get this? Okay, if you still remember, for Tn as in a what we call arithmetic sequence, actually we have a formula for it. If you still remember, Tn would be t1 plus bracket n minus 1 times d. Okay, so if you put that tn into the tn here, and so within the bracket that will be t1 plus another t1 plus bracket n minus 1d. So 2 t1 combines becomes 2 times t1, right? And n minus 1d is over here. So that how could we get that the general rule in the green box from the orange one? Okay, so most likely in the examination you are going to use the rule in the green box rather than in the orange box. But still, I think it's very interesting to see how could we get that formula or that rule for the series for first n terms. Okay, right, remember the formula. So let's apply the formula. So it would be the most straightforward questions. Okay, for the arithmetic sequence 10, 13, 16, 19, calculate the sum, okay, of first 20 terms. First of all, is arithmetic sequence. It's quite obvious because every time you add 3, okay, you need to find the sum of first 20 terms. So don't confuse with the question we've learned in arithmetic sequence. Sometimes we are going to find the 20th term, but this is not about the 20th term, so about the sum of the first 20 term. So that means you need to add all the terms together. You need to add 10 plus 13 plus 16, okay, etc. until t20. But we don't know what is t20. That's okay. You could still use the formula in the green box. Okay, so in the green box, that means n over 2. So how many terms over here? 20 divided by 2. Okay, then we open a bracket. Okay, and 2 times t1. Which one is t1? Is 10 plus how many terms? 20 terms. 20 minus 1 times, okay, difference 3. Okay, the common difference. Can we see the common difference right here? Okay, so plus 3. Okay, so common difference is 3. Alright, so you need to find the common difference. You need to know the number of terms. Then you need to, of course, see the first term. Then you could use the formula. Alright? Okay, let's simplify this a little bit. Okay, that's 20 plus 19 times 3. Okay, then you can use your calculator to do it. Okay, that will be it. Okay, that's okay. No problem for this one, right? Okay, still remember the formula, how to use it. Okay, good. We might copy this formula because we are going to use it again. Okay, so for the next question here, let me put the formula here again. Alright. Okay, for an arithmetic sequence, this one. So this time they give you the last term. Alright. Okay, so is this arithmetic sequence? You can check. Okay, so 28 to 24. If you use 24 minus 28, that's minus 4. And then another minus 4, another minus 4. Okay, so therefore you see the common difference is minus 4. Okay, and you need to find. So we know D is minus 4. Okay, so are we going to use this formula yet? No, because we don't need to use that. We don't have the information about Sn. Okay, so you need to know which term will give you minus 32. Okay, so that's the time. This time we are going to use the formula for our arithmetic sequence. If you still remember this one, okay, Tn is minus 32 T1 is 28 plus n minus 1 times minus 4. Okay? Have you got this? Okay, I move that 28 to the other side. We got minus 60 divided by minus 4, which becomes 15. Okay, because I'm doing this like paper 1, we don't have a calculator, right? Okay, so n equals 16. Alright, that's not bad. N equals 16. Oh, okay, so how could we find the sum of the terms? Sum means the series. So this time we know there are 16 terms. So the sum of all terms, we use S16. Okay, then we could use this formula. That's 16 divided by 2. 2 times the first term. First term is minus 4. Oh, sorry. First term is 28. Sorry about that. Okay, plus 16 minus 1 times d. d is minus 4. Okay? Right, let me get the value. Okay, so the sum of all terms is the same to our last term. Is that a coincidence? Possibly yes, right? So there's nothing wrong with this. It just happens, right? Okay, so that's how we find S16. Alright, okay, so another one. Okay, for this one, I'm going to give you some time to think about the sum of the first 30 terms. Alright. Okay, you might take some time to do it and check with my answer, right? Okay. Okay, so check the answer, right? Okay, so it's about the sum to 30, so you write S30, all right, use the above formula, use the formula for series. Okay, T1 is 10, D is of course 5, okay, so you got the answer, all right? Okay, boy is quite difficult. So for boy, I don't think simple and familiar. Possibly it should be complex and familiar, CF, right? Okay, so how could we do this? Because we don't know number of terms. Okay, so you need to let the number of terms be n. Okay, then we use the formula. We know that's n over 2. Okay, n 2 times the first term, which is 10, plus n minus 1 times that's 5 equals this one. Okay, so there'll be a lot of things to do, but first we might move that 2 to the other side, right? So let's simplify this. Possibly 2 times 10, 20. I'm going to multiply that 5 into the bracket. You multiply that 2 to the other side. So I've done multiple steps in one move because it's mathematical method, so we're not going to do too much basic algebra, right? Okay, so to simplify this, you might have 15 plus 5n 8600. Okay, then you might multiply the things into the bracket. You got this one. Okay, what does it look like to you? So you see n squared, n, so it kind of looks like a quadratic equation, right? So to solve a quadratic equation, let's rewrite them into the form that Okay, why should we write the form into this? Because for the quadratic form, it's always useful to see this form, right? Because for the question like this, it's very likely that we are going to use calculator. Okay, so let me show you how to use a calculator. Okay, remember the things now. The coefficient of that, the n square, normally we call x square, is 5, and the other 15 minus 8, 600. Okay, let's use a calculator to check. Okay, let's use. Okay, so in your calculator, you are going to find the menu and the algebra. To algebra, you need to find what? Sorry, let's do it again. You need to go to the polynomial tools. You need to find the roots of the polynomial. Alright, so degree should be 2 because that's quadratic. Roots real. Okay, so that's A2 means coefficient of x squared. So remember what's this? 5, 15 minus 8, 600. 5, 15 minus 8, 600. Okay, then, okay, press enter. Okay, so you see there are two roots, minus 43 and 40. Alright, coming back here. So that means you could say n equals 40, okay, n or minus 43. But of course, because this n means number of terms, so it can't be negative. So we just reject this one. So the only answer is n equals 40. Alright, so that's how we solve this question. Okay, good. Alright, so let's move to another one. Okay, so for the question here, things become more complex, right? Okay, so we know that's the sum of the first 10 terms of arithmetic sequence 100. If the fourth term is 7, find the first term and the common difference. So that two information. One information, first 10 terms 100, fourth term 7, find the first term and the common difference. Okay. So let's use the conditions first. Yeah, let's use the easier condition. Fourth term 7. So let's use this one. T4 equals 7. Okay. So how can we do this? We know that's T4 equals T1 plus n minus, that's 4 minus 1 times the difference, which is unknown at the moment. Alright, so that means you got T1 plus 3D equals 7. Okay, so we leave this bit behind and let's work on the other condition. Okay, so let's say we have S10 equals 100, right? So use our rule for series. We have 10 divided by 2 times T1, which is unknown, plus 10 minus 1 times the common difference equals 100. Okay, so let's simplify the things in the bracket. It becomes 2T1 plus 9D. So how about 10 divided by 2? That's 5, right? So when you move that 5 to the other side, 100 divided by 5 comes 20. Okay, so can we solve this one? No, because still got two unknowns. Okay, so when we see there are two equations, both in two unknowns, so it becomes simultaneous equations, right? So, but the first one seems simpler for us, so let's change the first one into T1 equals to 7 minus 3D. By doing so, I single out that's T1. Okay, I call this first equation. Okay, so I'm going to say this is second equation, and I'm going to substitute that's 1 into 2. 7 minus 3d plus 9d 60, sorry, plus 9d 20. Okay, so coming to this part, you will have 14 minus 60 plus 9d would be 3d 20. Okay, you move that 14 to the other side, becomes 6, d becomes 2. Okay, so we got the common difference as d. How could we find the first term, t1? Okay, of course we can use the first equation. By using the first equation, we will have this one by 1. Alright, so that's 1. Okay, that's done. Okay, so that's basically you need two equations. You need two equations to solve it. Okay. Okay, so the second one is quite similar to the above one. I'm going to give you some time to do it, and after that we'll check the answer. Right? Okay. Alright, so let's check the answer. Right? Okay. So if you got common difference d equals minus 5, t1 equals 20, then congratulations, you got the correct answer. Okay, so if you got something wrong, very likely would be algebra skills. Okay, you might track some of the steps. You might look back to our previous week, the last question to see if something wrong. If you still can't see it, you can send me the question. I will help you to fix the mistake. Alright, so basically you are going to set up two equations as well. Okay, the first equation is over here, and the second equation over here. So after you set up two equations, alright, I hate this. Alright, after you set up two equations, then it will be possible for you to substitute one into the other, and by doing so you will have one single unknown to solve for, and you got the answer. Alright, okay, so here's another one. So this one could be a bit difficult. It's complex and familiar. To pile up 440 logs. Workers decide to reduce 2 log each layer from the bottom to the top. It is found that the number of the log at the top is 3. Okay, so imagine just like there's a lot of logs over here. We don't know how many, and each layer you reduce 2. So let's suppose you reduce 2 for 1 from each side. Okay, so it will piles up like this. Okay. And we don't know how many layers, but at the top there's only 3. Okay, so we don't know how many layers. Okay, but we know there are 440 logs, and also we know each layer will be 2 less than the bottom one. Okay, 2 less than the one below it. Okay, if you count from the top, from top to bottom, then each layer will be increased by 2 units. It depends on what's your first term, right? Okay, so calculate the number of layers for the piles of the logs. You might think about this. what kind of formula are you going to use? Are you going to use the sequence formula, or are you going to use the series formula? Sequence or series? Okay, for sequence it would be like the a particular term would be a certain number, but for series it's the sum of number of terms. First number of terms will give you a number, right? So, but in this case, I would say, because they give you total number of logs, so it seems to me it should be using series, okay? But we're going to find the number of layers, okay? So that means you need to find n equals to what? Okay, so that means we don't know n, but we know the sum will be 440. Okay, so let's write the formula then. It's like n divided by 2, okay, and 2t1. So what's t1? Because we don't know the bottom layer, but we know the top layer will be 3. So that's t1. t1 equals 3. Okay, so 2 times t1, 2 times 3, plus, okay, n minus 1 times d. What's d? Okay, from each layer to the next one, there will be 2 more or less. But since your first term is the top layer, so the second term would be 5, right? So the difference should be positive, should be 2. And the total would be 440. That's it. Okay. Okay, let's see how could we solve for this one. Okay, so your task is to solve for that n. Okay, let's try to solve it. First, when you see the bracket, you got 6. You might multiply that's 2 into the bracket. You got this one. Okay, but how about n over 2? We might like that 2 multiplied to the other side, right? So that's what I'm going to do. I'm going to multiply the 2, the denominator, over here, because that's n over 2 outside the bracket. If you multiply 2 by both sides, that's 2 will shift to the other side. Right, so then when you simplify the bracket, you got this one, or this one become this one. Okay, let's multiply that's n into the bracket. You might have this one. Okay, so can you see what kind of equation it is now? It is quadratic equation. Can we solve this quadratic equation? Yes, we can. Okay, so how can we solve this? Remember, we could use our calculator. Okay, let's start. Okay, sorry. Okay, so let me show you again how to solve it. Algebra, polynomial 2, find roots. Okay, degree 2. Okay, still remember the numbers. 2, 4 minus 880. Okay, 2, 4 minus 880. Okay, so let's see. Okay, so there are 2 roots, minus 22 and 20. Okay, so let's say okay, of course, n must be positive integer, right? So this one is rejected. So the only answer is n equals 20. So that means there are 20 layers. Okay, so let's say there are 20 layers. Okay, would that be good? Okay, boy. Okay, if there are 40 logs shipped to the site, sorry, after the pile has been mounted, determine the number of logs should be added to each layer so that there's no increase in the number of layers of the pile. Okay, so that means you got some new new logs, but the pile is already there. So you need to add your logs into the, um, the pile, but without change the rule of the pile that each layer should be more than um, should have two more logs than the layer above. Okay, so how number of logs will be added to. Okay, so let's think about this. If you got 20 layers, okay, sorry, if you got 20 layers, what you can do without change the rule of the pile, you can add certain number to each pile without change the fact that it's still arithmetic sequence, right? So, but now you got 40 new logs. So let's see, for each layer, okay, each layer can be added by 40 divided by 20. There are 40 logs, there are 20 layers, 2 extra logs. Okay, so it's an integer, so that's good news. So each layer you can add the 2. So that means originally the bottom layer is of the number 20. Now you add 2, become 22, right? And the layer above it was once 18 logs, but now you add 2, becomes 20. Okay, so the sequence simply is still arithmetic sequence, but you just add 2 each time. All right, okay, that's it. That's for our question 5. Right, so question 6 is also complex and familiar. I use some of the names of our classmates. Okay, I use Shay, John, and Alena as our subjects for the question. Okay, so I'm going to give you some time. Try to think about this, all right? Okay, to see if you could understand the question and try to set up the rules for solving it. So it's complex and familiar. Possibly, if you feel not quite familiar with the things we've just learned, you might spend a bit more time on doing some practices uh, in your notes, and also you might rewatch some of the uh, questions in the video. All right, but anyway, I suppose you are ready now, so I'm going to show you how to do part A. Yeah. Okay, for this part, okay, it's about a guy called Mr. T who assigned his students to finish 100 questions during the COVID-19 break. He's such a good guy, right? Okay, Shrey decided to do 8 questions first day. Okay, so we know Shrey is a very diligent student, and she tried to increase the number of questions by 2 each day. So that means the first day she's going to do 8, second day she's going to do 10, third day 12. Okay, calculate the least number of days she would take. Okay, at least how many days she would finish the 100 questions. Okay, let's try to do it. Of course, you can add all the numbers up until you exceed the 100. That's okay, but I just want to use our method, the method we just learned. All right. Okay. So in Shay's case, T1 is 8, D is 2, S100 is not S100. It's Sn. Okay, because we're not quite sure how many days she's going to take. Must be 100 or more. Okay, one more, because it could be more than 100, right? But we assume it's 100 in the first place, right? So a formula would be like this. For Sn equal to 100, we got n over 2 times t1, okay, and we got n minus 1 times d, and we got the sum, the whole thing equals 100, right? And we need to find n, all right? Okay, remember, normally we are going to move that 2 to the other side as our first step. And we simplify the brackets. So where's the 2? So we multiply 2 on this side. Okay, and we simplify the things in the bracket. Okay, and then we multiply n into the bracket. Okay, and then we just rearrange the terms to make it quadratic. Okay, then you need to find n. Alright, okay. Let's use calculator again. Okay, let me check anything wrong about this. This should be okay. Alright. Okay, it's 214 minus 20. Okay, 214 minus 20. Okay, so I'm not going to repeat that process. Oh, I just forgot. 214 minus 20. Minus 20. Okay. Okay, I need to make sure I switch off the document setting. You need to make sure that CS mode off, otherwise you will see a answer with short form. That's not what we're going to find. Okay, alright, so that two answers. One is minus 14.09, the other is 7.09. Okay, let's see if we can copy this. Right, can we? Oh, we can't. Okay, so here. So okay, so basically one is minus 14.4, 7.9. Okay, so I need to copy it, otherwise I can't write here. Okay, so for calculator, you know that n is minus 14.09 or n equals 7.09. Okay, of course this one is going to be rejected. So n 7.09. Okay, does it mean around 7 days? Okay, but you know it's more than 7. The question is about at least. So at least this number of days she should take. So she should take more than 7. Otherwise it would still unfinished, right? So it should be n equal to 8. Okay, so let's have a track if that's really the case. Okay, so let's have a track. Okay, we know first day she is going to do 8 questions, 10, 12, 14, 6, 18, 20, 22. Yeah, so that's 8th day, so this T8, right? Okay, let's say if we add all the terms up to 20, which is T7, what answer do you get? Okay, so if we add all the terms T1, T2 up to T7, what number do you get? You can use your calculator to see. So that would be 98. It's very close to 100, but it's not there. So that's why you need to add another 22. Okay, so if you add all the way to T8, then become 10. Yeah, it become 120. So yes, of course it surpassed 100 question, but that's only 100 question. But the answer still would be 8 days, all right? Because by 7 days, she still got 2 questions to finish. Okay, so that's the first part. Let's say the second one, John. Okay, John had only 5 days to finish. Okay, he's in such a hurry. Okay, all the questions, and he decided to start with 15 questions on the first day. Oh, so she got 5 days to finish. 15 questions on the first day. Okay, determine how many should he increase the number of questions he finish each day. So each day he need to increase number of questions, otherwise he can't finish. Can he? Because if he only do 15 questions per day, after 5 days, how many questions he's going to do? He can only finish 75 questions, so he can't finish 100 questions as assigned by Mr. T, and Mr. T will be very disappointed if he only handling 75 questions instead of 100 questions. Okay, so that means for John, he needs to do a bit more after for each day after the first day. So for second day, he need to add certain number of questions. Okay, so for John, the sequence would look like first day 15, second day 15 plus D, but we don't know D, but we know you should keep adding that. Okay, and up to the 5th day. Okay, and he must, when we add all these things up, then the question he has done should be more than 100. Okay, right? Okay, so let's see how could we solve this by using the rule we've learned, right? Okay, so for John, T1 is 15. D is unknown, but we know number of days must be 5 days. All right, so let's see how can we do it. So we know again as 5 must be 100. So okay, so the formula should be from S5 to 100, 5 over 2 times T1 plus 5 minus 1 times D equals 100. Okay, so the things in the bracket becomes this one. That's 2.5. Okay, and you divide that's 2.5 by 100. Sorry, 100 divided by 2.5. So that would be 40, right? So, 40. Okay, so that's the sorry, we know T1. Sorry, that's my mistake. So that's why I feel a bit strange. Okay, so that means we can do that as 2 times 15. Sorry for the confusion, because I forgot that we've already got T1. Okay, so solving this, you take that 30 to the right hand side, becomes 10. D becomes 2.5. Okay, so each day after the first day, he needs to add at least 2.5 questions, but we can't do 2.5 2.5 questions. All right, so that means at least he needs to add 3 questions each day. Okay, 2 or by 3 each day. Okay, by 3 more than the previous day. Okay. Alright, so that would be our part B. Okay. The last one is our Lena one. Okay, try to understand the questions. Okay. You might take some time to try the question before I show you how to do it, right? Okay, so here's the answer, right? So for another Lennox case, so he's going to finish all the questions within 10 days, exactly in 10 days. Okay, and the number of questions he increased by each day is 2, so that means the common difference for the sequence should be 2, and also she still needs to finish the all 100 questions by Mr. T, right? So that means S10 equals 100, but the question is how many questions she should finish on the first day. So in her case, the problem is T1, so she needs to find T1. Okay, so our equation shows like this. So all you need to do is move term to the other side, make sure you know how to do the algebra. You got T1 equals 1. Okay, so that's all the question I would like to show you for geometric series. Remember, for arithmetic series, remember a series just a sum of a number of terms in the sequences. All right, and Sn will be the sum of the first n terms. Also, for a arithmetic series, you need to apply the rule in the green box. Okay, the green box. So every time you need to ask yourself which quantity is given, okay, which is not, okay, right? And that's it. Okay, so if you have any question, please you might send your question through email, or you can go to OneNote if it is recovered, and write your question in the collaboration area space. Alright, also in the notes this time I leave some space for some of you who might want to photocopy the questions and photocopy the whole notes and do their work on the sheet. That's okay. And if you finish all the video and you think you understand the ideas, you can go to do some practice. Okay, some of the questions are really very basic. Some word problems could be quite difficult, but I got the answer in the end. Okay, yep. Just try your best. Okay, see you next time.